All right, let's move on to the next page, number 7 and 8, and then we're going to finalize the notes for today. So our pathway right now is we will do 7, 8, and 9. After we're done with the note taking today, I'll also help you guys a little bit, like halfway through number 13, just only manipulating the equation. I'm not going to graph it. So let's manipulate the equation. Afterwards, number 13, 14, and possibly 19, but I'm not going to graph it. So you guys will do the rest on your own. Okay, let's do number 7. I think I forgot to say that number 6 was a special case. That was special case number 1. If you have parallel lines, then you are going to write no solution. Here is special case number 2. Let's start graphing it already. Well, good thing the top one is already in slope-intercept form. Let's graph this. I'm going to start on 3. And then our slope is -2/1. So this means we go 2 down and 1 to the right. So let's go ahead and do that. 2 down, 1 to the right. 2 down, 1 to the right. Oh. The bottom equation is in standard form, and we're going to have to do some manipulations to turn it into slope-intercept form. Students, what would be your first step to manipulate or change this equation? -4x on both sides. Because right now this is a positive 4x. So we're going to do the opposite. -4x on both sides. Okay. So 2y is equal to, next question, 6 minus 4 is 2. So should I put 2x over here? Why not? So these two are not like terms. So I'm going to put the -4x first. And then since this is a positive 6, we're going to go plus 6 over here. Okay. Last step, please. Divide everything by 2, 2, and 2. Y is equal to -4 divided by 2, please. -2x. 6 divided by 2, 3. What do you guys notice? They are the same line. Okay. Okay. What is that? I think that's correct. Listen over here. Okay. If it's the same line, it is up to you if you want to regraph it. You don't have to. It's not required. But I'm just making a visual right now of what's happening. So it's the same line. You're just really putting that line over the same line. Okay. So I graphed the green first, and then on the hot pink, I graphed it again so that you guys know it's the same line. Here is special case number 2. If we have the same lines, if we have the same lines, this is what your solution is going to be, or what you're going to write. You are going to write infinite solutions. Infinite solutions. One reason why we write infinite solutions is because they're the same line and the same equation, we actually could plug in any x that we want, and we're going to get the same y value. If you plug in 0, actually, let's go plug it in. What is -2 times 0? 0. And 0 plus 3? Sorry, 0 plus 3 again? 3. So both of them are going to come out with 3. If you plug in the same x value, maybe 1, you'll get the same y value. If you plug in -1, you're going to get the same y value. So now it doesn't matter what you plug in. You have so many solutions to work with. So many x's will work for you. So this is why it's infinite solution, because this is the same line. We are now going to summarize, do some patterns, and then starting from number 10 is classwork, homework, but I'll do a couple problems halfway with you guys. Let's summarize. I'm going to make it into 2 columns. The first column, sorry, I misspelled it, scenario, that's a C. The scenario and the solution. The first scenario was, sometimes the lines intersect. If the lines intersect, and then you can look at example number 5 on the same paper. What does your solution look like? Well, it should be a coordinate point x comma y. So for example, on example number 5, the solution was negative 3 comma 2, because that's where the point of intersection was, negative 3 comma 2. Second scenario, if the lines are parallel, again, this is shorthand for parallel, and we did that on example number 6. You have to look back on your notes. What were the 2 words that we had to write if the lines were parallel? No solution, because there were no points of intersection. So your solution is no solution. And then the third scenario that we just did, if we're graphing the same lines, and we did that on example number 7 or number 7, what 2 words will you write for your solution? Infinite solution. We can plug in any x that we want. Because they're the same lines, it'll come out to the same y value. Infinite solutions. Sometimes on your answer key, it will say infinite number of solutions. It's the same thing as infinite solutions. Okay. When you have time today, I think this chart would be a really nice chart to put on your toolkit, as well as some of the couple problems, as well as maybe changing some of these equations from standard form to slope-intercept form. I think those would be really nice things to put on your toolkit. Okay, let's do number 9, and then we'll slightly do a couple of the homework problems. That's it for me. The rest of you guys will do classwork homework. Okay, for number 6, this is number 9. The system had parallel lines, which led to a no solution or infinite solution. Which led to a no solution. It's circled at. Parallel lines have same slope or different slope? Same. They have the same slope, but same y-intercept or different y-intercept? Different y-intercept, yes. Okay. The system had parallel lines, which led to no solution. Parallel lines have the same slope, but different y-intercept. And you know what? I might as well just go back quickly to number 6. Is that true? Well, take a look at your lines. Yeah, same slope, 1 over 3, 1 over 3. But the starting position is in different places, negative 4 and plus 3 over here. Let's finish off number 9. For number 7, the system had the same line, which led to which one? Infinite solutions. Circle that. Well, hopefully I'm not being redundant. Same lines have the and the same y-intercept. Okay. Right. Technically, right now it is classwork time, numbers 10 to 19, but I'm still going to record. If you want to follow along with me, we'll do a couple problems of changing the equations, and then the rest of the time will be your time. Okay, so if you want to follow along, I'm going to actually jump to number 13, and I just want to manipulate this equation over here. So 2y is equal to 6x minus 6. Actually, we only have to do one more step, and I already said it. What are you going to divide both sides by? 2. So divide by 2, divide by 2, divide by 2. 6 divided by 2. 3x, and then minus 3. Okay, so like I said, you will graph this, I will not graph this. Okay, so y equals 3x minus 3. Okay, if you want to follow along some more, let's do number 14, manipulations or changing the equation. Okay, the top one is already in slope-intercept form. We just got to do this bottom one over here. 6x plus 3y is equal to 21. Okay. All right, for those following along, what is going to be your first step? Well, actually, I even wrote it. Minus 6x on both sides first. Yeah, let's go ahead and do that. So minus 6x, minus 6x. 3y is equal to, okay, be careful, these are not like terms, negative 6x plus 21. Okay. And then divide everything by 3. Y is equal to negative 2x plus 7. And then you guys will deal with that a little bit later. Okay. I definitely want to do number 19 with you guys. So now let's jump all the way to number 19. I want to do the very bottom of number 19, this one, x minus 2y equals negative 8. X minus 2y equals negative 8. Okay. What would be your first step into changing this equation? How so? Minus x on both sides, minus x and minus x. Good. Be careful. What are you left with on the left side? Negative 2y. Negative 2y equals negative x minus 8. It's a lot of negatives, yes. Before we divide, though, what goes in front of the x? A 1. Okay. And then now divide both sides by, not 2, negative 2, negative 2, negative 2. I really want to do number 19 because on your guys' previous test, some of you guys are not canceling out the negatives. What I mean by this is, what is negative 1 divided by negative 2? Is that negative or positive? It's positive, so please be careful. All the rules that you guys have learned on previous courses, apply those as well. Okay, so this is going to be positive 1 over 2x. And then what is negative 8 divided by negative 2? Positive 4. So please be careful with the double negatives. That will turn into positive. Okay, so instructions again. Please do numbers 10 to 19. I'll pass out the answer key in a bit. When you are totally done, let me know if you need extra sheets of the toolkits. You guys will get the toolkits. For those who haven't finished test corrections, please do test corrections. If you're done with all of that, then it will be Matthew.